In this video, I will demonstrate how to use Vericut to check NC program code that was written in a text editor. I will be using the 3-axis CNC milling programmer practice project, Operation 2, as the example. Before you get started, you will need to download and install Vericut and activate the license. Then download the practice project and unzip the folder. Inside that folder, you will find a project folder. Inside the project folder, you'll find a manual coding folder. And inside that, you will see a Vericut project file for each operation. In this example, we're going to be looking at operation 2, which is the first operation that you will be programming on this 3-axis milling sample or practice project. So when we open the op2 Vericut project file, you will see the very top file is a Vericut template or project file. Double click the project file and Vericut will open. And you should see this mini mill, and the setup should look just like this. In the graphics window, you can use the mouse wheel to zoom in and out. And we are going to make the guards invisible so that we can get a better look at our part. If you right click on the machine guarding and select enclosure, invisible with subcomponents, the door and guarding will disappear. And now we have a clear view of our part held in pocket jaws on the machine. So the next step is to take the NC program file. You will start with the template. You will start with the op2 milling template text file that you'll find inside the project folder. Open that in your text editor and begin writing your code. You don't need to complete your program before testing it in Vericut. And in fact, you can keep it open, and as you write, you can test it, go back to your text editor, make edits, save those edits, and test the code until you have it complete and free of errors. So once you have a NC code text file created, you're going to left click that file and drag and drop it into the project tree over top of NC programs. And when you do that, you'll see that you now have 2 programs, the one you dragged and dropped in and a template file. We want to deactivate that template file by right-clicking and click active, and now it will be in italics and the template will no longer be active. Your program will. So to view your program as it's simulating, you want to select info and from the menu bar and NC program, and a NC program dialog box appears, and you can position that, drag it wherever it's not in the way. The arrow points to the current line of the program that's being executed. To execute this program, we are going to press play in the lower right corner. And the program will continue to execute unless a collision is detected. We have our first collision, and the arrow is pointing toward a Z move, Z minus 0.5. That should actually be Z plus 0.5. So in our text editor, we can find that mistake, correct it, save it, and go back to Vericut and click reset. And you will see that clicking reset cause the changes to be effect in Vericut. So we're going to play this again. And while it is playing, we can control the speed with this slider bar. Slow it down to get a better look, speed it up to get through it more quickly. Okay, the simulation has completed. No more collisions, but something looks wrong here. It looks like maybe too much material has been removed from this finger. So to check the machined part against the design model, we're going to select Analysis from our menu bar, Auto Difference. And in the Auto Difference window, we can set the tolerance. The default is here is 0.002, and you're going to click Compare. Wherever there is excess material, it will be colored dark blue. Wherever there is a gouge, it will be red. Here we see dark blue where the side holes would be located, and that's to be expected because the side holes are machined in the next operation, so there's nothing wrong there. The top of this finger, however, is red, indicating that too much material was removed or the part is gouged. So we have to look at the toolpath that machined the top of the finger and the toolpath that machined the dovetail portion of the finger. We'll go back to our NC program file and find the code that finished the top of the fingers. And the Z coordinate should be 1.125. Here's a mistake. We'll correct that. And then let's look at the dovetail toolpath and see if we can find the mistake there. The X coordinate for finishing the dovetail is 0.15. The rough pass should be more positive. That should be 0.16, not 0.12. So let's save these changes. Go back to Vericut. We can close our AutoDiff window, reset our simulation, and zoom back out. Hit play, and now the corrected version of our program is running. And we can speed through this. All right, simulation is complete. Let's take a look. Visually, it looks better. Let's try checking it to the design model. Again, we're going to select Analysis, Auto Difference, and Compare. And now we're seeing no red, so there's no gouges. And the only excess that we see, dark blue, are the holes that get machined in the next operation. So our program has machined the part successfully. So we can now take our saved program and submit it as finished work. Before you begin writing your program, be sure to put your contestant ID in the header of the program. That will help identify if your program should get mixed up. Okay, that concludes this demonstration. The steps in checking a lathe program are very similar. Every project, each operation of every project has its own Vericut project folder and project file that you will open to begin your verification.